Hello students and good morning. So now I am doing class for class 12, class 12 science. The topic is integration of some special form of functions. Okay, integration of some special form of functions, and in the last online class also we were doing the same chapter. So today is the continuation class. Same exercise 8, page number 396, 4 mark section from the book Higher Mathematics for class 12 by SND. So let us evaluate this integration. So let's do this question number 5. So you have to integrate this function, that is integration of dx divided by within square root sin x into cos to the power 7x. So how can you do this integration now? So let us integrate it. So let us write here, so capital I, that means we are integrating it. So capital I is equal to, this is the given integration, so integral sin dx divided by within square root sin x into cos to the power 7x. Okay, so in this case you cannot directly integrate this function, so you have to simplify the expression within square root, right? So how can you simplify the expression within square root? Okay, now let us convert this sin x and cos to the power 7x in terms of tan x. So if you want to convert this sin x into tan x, you have to divide this sin x by cos x, so that we can write sin x by cos x is equal to tan x, right? So therefore I is equal to integration of, that is dx divided by within square root, we can write here sin x divided by cos x into, this is cos to the power 8x. Is that clear now? So I think you have understood it. Okay, so or I is equal to integration of dx divided by, now within square root, this sin x by cos x is tan x into, and this one is, you can write it as cos to the power 4x whole square. So this cos to the power 8x is written in terms of whole square, that is cos to the power 4x whole square. So what is the square root? You can easily get the square root of cos to the power 4x whole square, that is I is equal to integration of dx divided by, what is square root of cos to the power 4x whole square? That is your cos to the power 4x only. Here is square root and this square will be cancelled. You will get cos to the power 4x into root over tan x, into root over tan x, right? So next, or I is equal to integration of, what is 1 by cos to the power 4x? You know that this is sec to the power 4x dx divided by within square root, we have here tan x. Now the expression tan x is within square root and it is in the denominator, and you know that the differentiation of tan x is what? Differentiation of tan x is sec square x. So let us break this term, sec to the power 4x as I is equal to integration of, this is sec square x into sec square x dx divided by within square root, this is tan x. Okay, now you know that the differentiation of tan x is sec square x. So one of the sec square x, one of this sec square x is kept as it is, and you have to convert this other sec square x in terms of tan x. And what is sec square x in terms of tan x? I is equal to integration of within bracket, this is 1 plus tan square x bracket closed into sec square x dx divided by within square root, this is tan x. So I think you have understood it. Okay, so now since you know that the differentiation of tan x is sec square x, we can assume tan x as z. But since the expression is on the square root and that is in the denominator also, you can assume tan x as z square. Let z square is equal to tan x. So let us write here differentiating both the sides, with respect to x. So it is 2z into dz by dx is equal to, this is your differentiation of tan x is sec square x. Okay, now let's do cross multiplication, or 2z dz is equal to, this is your sec square x dx, right? So now let us put it in I is equal to integral sign within bracket 1 plus, since tan x is z square, what is tan square x? It is z square whole square, right? So this is z square whole square. Is that clear? Tan x is z square. What is tan square x now? It is z square whole square. 1 plus z square whole square bracket close. And what is sec square x dx? That is your 2z dz. That is your 2z dz divided by, in the denominator within square root there is tan x. So within square root z square. What is root over z square? That is your z. So here z gets cancels. So constant term you can take it outside. I is equal to 2 integral sign within bracket 1 plus z to the power 4 bracket closed dz. So I think you have understood it. So now you can separate the term, or I is equal to 2 integral sign dz plus, what is the second term? 2 integral sign, this is z to the power 4 dz, or I is equal to, this is your 2z plus 2 into z to the power 5 divided by 5 plus c. So I think you have understood it. Okay, now you have to put the value for z. So what is the value for z actually? Since z square is equal to tan x, what is the value for z? It is root over tan x, or I is equal to 2 root over tan x plus 2 by 5, and this is z is root over tan x. You can write root over tan x whole to the power 5 plus c. So, or I is equal to, this is your 2 root over tan x is kept as it is plus 2 by 5, and this can be written as, you know, root over is whole to the power half, so you can write it as tan x whole to the power, this is 5 by 2 plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. That is, you have to evaluate this integration. That is integral of cos square x divided by sine to the power 4x dx. So how can you evaluate this integration? So let us write first, I is equal to integration of cos square x divided by sine to the power 4x dx. Okay. So now let us simplify it first. You can break the term. You can simplify this term. You can simplify it as I is equal to integration of, this is cos square x divided by sine square x into 1 by sine square x, right? Then you should write dx here. Or I is equal to integration of, what is cos square x by sine square x? It is cot square x into, what is 1 by sine square x? It is cosec square x dx. So I think you have understood it. Okay. So now you have to check the relation between cot square x and cosec square x, or it may be you have to check the relation between cot x and cosec square x. So you know that the differentiation of cot x is minus cosec square x, is differentiation of cot x is minus cosec square x, isn't it? So let us assume let z is equal to only cot x. Let z is equal to cot x, because the differentiation of cot x is minus cosec square x. So let us write here differentiating both the sides with respect to x. So it is dz by dx is equal to minus cosec square x. dz by dx is equal to what? Minus cosec square x. So let us get the value for dz, or dz is equal to minus cosec square x dx. Is that clear? So minus sign is taken to the left hand side, or minus dz is equal to cosec square x dx. That is cosec square x dx is equal to minus dz. So let us put these values in I. So I is equal to integration of, what is cot square x? It is z square. It is z square into, what's about this cosec square x dx? It is minus dz. It is minus dz. Or I is equal to, this is minus sign is taken outside, integral sign. So it is z square dz. Or I is equal to minus, what is integration of z square? It is z cube upon 3. Then you have to write down the constant of integration. Okay, so now let us put the value of z. Or I is equal to minus 1/3. What is z actually? Z is cot x. What is z cube? It is cot cube x plus c. So this is the final answer. Is that understood? So you can copy it. Now we'll do the next question, that is question number 7. So now we will do the next question, that is question number 7. You have to evaluate this integration, that is integral of sin square theta d theta divided by 1 plus cos theta whole square. Okay, so how can you evaluate this integration? So let us first write capital I, that is, this is the integration, this is the integrand which is to be integrated. The function, I already told you that the function which is to be integrated is known as the integrand. So let us write I is equal to, that is integrand, the first letter is I. So that's why we are writing capital I is equal to, that means we are integrating the given function. So capital I is equal to integration of, this is your sin square theta d theta divided by 1 plus cos theta whole square. So you cannot directly integrate the given function or given trigonometric function. So first of all, you have to simplify this trigonometric function. Let us simplify it. Since the denominator is given in terms of cos theta, you can change this sin square theta in terms of cos theta. We can write down 1 minus cos square theta in terms of sin square theta. Let us convert this sin square theta into cos theta. So I is equal to integration of, what is sin square theta in terms of cos? This is 1 minus cos square theta divided by 1 plus cos theta whole square. Then you can write d theta. Okay? Or I is equal to integration of, now in the numerator, we can write down the formula a square minus b square. 1 can be written as 1 whole square. This cos square theta can be written in terms of whole square, that is cos theta whole square. This is your cos theta whole square divided by, this is 1 plus cos theta whole square. Then you can write d theta. Okay, so now let us simplify the numerator. So we can use the formula of a square minus b square. You know that this is a plus b into a minus b. Or I is equal to integration of, in the numerator here, a is 1 and b is cos theta. So it is a plus b into a minus b. So we can write 1 plus cos theta into 1 minus cos theta. That is a plus b into a minus b whole divided by, denominator is kept as it is. That is 1 plus cos theta whole square. So you can write here 1 plus cos theta whole square. Then you can write down d theta, right? So here you can cancel this 1 plus cos theta square will be cancelled, or I is equal to, what is the expression now? It is 1 minus cos theta divided by 1 plus cos theta. Then you can write d theta. So I think you have understood it. So again you can simplify it. You can use the formula from submultiple angle. So what is the formula for 1 minus cos theta? I is equal to integration of, what is 1 minus cos theta? This is 2 sine square theta by 2 divided by, what is 1 plus cos theta? This is 2 cos square theta by 2. Then we can write d theta. So here these two will be cancelled, or I is equal to integration of, what is sine square by cos square? This is your tan square theta by 2, then d theta. So I hope you have understood it, but you cannot integrate this tan square theta by 2 d theta directly. There is no formula for integration of tan square theta by 2. But you know the integration of sec square theta by 2, isn't it? So let us convert this tan square theta by 2 in terms of sec square. So what is the formula now? I is equal to integration of, what is the formula for tan square theta by 2 in terms of sec square? The formula is sec square theta by 2 minus 1 bracket close d theta. Understood? So now let's separate it. Or I is equal to integration of, this is sec square theta by 2 d theta minus integration d theta minus integration of d theta. Or I is equal to, what is integration of sec square theta by 2 d theta? This is just like your integration of sec square mx dx. What is integration of sec square mx dx? Tan mx by m. Here instead of x there is theta, m is half. So the formula is tan theta by 2 divided by m. M is half here. Minus, what is integration d theta? It is theta plus c. Or I is equal to, now when you simplify it, when this half goes up in the numerator, it becomes upside down. So it is 2. 2 goes up in the numerator. So it is 2 tan theta by 2 minus theta plus c. So this is the final answer. So I think I've understood it. So you can copy it. Now we'll do the next question. So now we'll do question number 8. That is, you have to integrate tan cube x dx. So how can you integrate it? So let us write I is equal to integration of tan cube x dx. So how can you evaluate this integration? That is integral of tan cube x dx. You cannot directly integrate it because there is no formula for integration of tan cube x dx. Okay. So let us simplify it. Let us break the term as, integration of tan cube x can be separated as tan x into tan square x dx. Okay. So now how can you evaluate this integration? You know that the differentiation of tan x is sec square x. So let us convert this tan square x. Whenever there is tan square x, you have to convert it into sec square x, as we have done in the previous problem. Okay. Whenever you have cot square x also, you should convert it into cosec square x minus 1. Similarly, this tan square x should be converted into sec square x minus 1 because the differentiation of tan x is sec square x. Okay. So, or I is equal to integration of, this is your tan x and within bracket tan square x is, this is sec square x minus 1 bracket closed. Then you can write dx, right? So let us separate the term now. I is equal to integration, or let us multiply it and separate integral sign and dx also. Integration of this is tan x sec square x dx minus this minus sign, integration of tan x into 1 is tan x dx. This is tan x dx. So I think you have understood it. So here in this case you have to do the method of substitution, because the differentiation of tan x is sec square x. Let us mark it as I1. I is equal to I1 minus, you can easily integrate it. What is integration of tan x? It is log within mod sec x, the base is e, then you can write plus c. So now let us evaluate this I1. Let I1 is equal to integration of, this is tan x into sec square x dx, right? And you know that the differentiation of tan x is what? Sec square x. So in this case you can do the method of substitution. Let z is equal to tan x. So now let us differentiate it. Differentiating both the sides with respect to x. So what do we get? So dz by dx is equal to differentiation of tan x is, that is your sec square x. Is that clear? And next, let's do cross multiplication, or this is dz is equal to sec square x dx. So we have got the value for sec square dx as dz. So what does I1 become now? So I1 is equal to integration of what is tan x, that is your z. What is sec square x dx? That is your dz. Or what is I1 now? I1 is equal to z square by 2 plus c. Or now I1 is equal to, what is z square? Since z is equal to tan x, what is z square? It is tan square x by 2 plus c. So we have got the value for I1, but this is not your answer. The answer is I. So let us put this value for I1 in I. So therefore I is equal to, what is I1 now? I1 is tan square x by 2. Tan square x by 2. You don't have to write c out here because c is already written here. 1 c will do. One of these constant of integration c will do it here. Okay? That is, only one constant of integration should be written in answer. While writing the answer, only one constant of integration, that is c, should be written. Okay? So I is equal to tan square x by 2. I is equal to I1 is tan square x by 2, and then minus log, you don't have to write down this c. Okay? Minus log within mod sec x, the base is e, then write down plus c. So only one c should be written. Only one c, that is constant of integration, should be written. So that is the final answer. So I think you have understood it. So you can copy it. So similarly you can do this at home. So you can evaluate this integration. This is not from the book. That is integration of cot cube x dx. So instead of tan x, it may be cot cube x. So similarly you can do this problem. So this is your homework, right? So this is your homework. So how can you evaluate this integration? You can write it as cot x into cot square x dx. And you know that the differentiation of cot x is minus cosec square x. So convert that cot square x in terms of cosec square x minus 1. Okay? Then separate the term. First integration, take it as I1. And the second integration, you can easily evaluate that integration, second integration. And first one, you have to do the method of substitution. So similarly, you can do that problem, that is integration of cot cube x dx. So you can copy it. Now we'll do the next question. So now we'll do question number 9, that is integration of cot to the power 4x dx. So therefore I is equal to integration of, this is cot to the power 4x dx. So here also, how can you evaluate this integration? So it is integration of cot to the power 4x dx. Let us break the term now. Cot square x into cot square x. And you know that the differentiation of cot x is minus cosec square x. So one of these cot square x should be changed into cosec square x minus 1. Okay. So or I is equal to integration of, this is your cot square x into cot square x dx. Or I is equal, you know that the differentiation of cot x is cosec square x. So let us convert this second cot square x in terms of cosec square x. So integration of, this is your cot square x into, this is cosec square x minus 1 bracket close dx. Or I is equal to integration of, let us multiply it. This is cot square x into cosec square x dx. This is the first term we are multiplying and separating it. Then minus sign, integration of cot square x into 1 is cot square x dx. So I think you have understood it. Okay. So now you can easily evaluate this integration, first integration. That is, you can do the method of substitution. And for this second integration, let us change this cot square x in terms of cosec square x minus 1, because you know the integration of cosec square x, right? So or I is equal to integration of, this is cot square x into cosec square x dx minus integration of, this is your cosec square x minus 1 bracket close dx, right? Or I is equal to integration of cot square x into cosec square x dx, integration of cot square x cosec square x dx minus, let us separate the term, minus integration of, this is cosec square x dx, this is cosec square x dx, next minus into minus plus, and this is integration of dx. Is that clear? So next, or let us mark it as I1, because in this case we can use the method of substitution. So now what is integration of cosec square x? So integration of cosec square x is minus cot x. So minus into minus plus, this is cot x, then plus, what is integration dx? That is x plus c. So let us write c out here. Okay. So let I1 is equal to integration of cot square x into cosec square x dx, right? So you know that in this case you have to do the method of substitution, because the differentiation of cot x is minus cosec square x. So let us assume, let z is equal to cot x. So let us differentiate it, differentiating both the sides, with respect to x. Therefore dz by dx is equal to minus cosec square x. So let us cross multiply. So dz is equal to minus cosec square x dx. Let us get the value for cosec square x. Minus is taken to the left hand side. So minus dz is equal to, this is your cosec square x dx. So we have got the value for cosec square x dx, which is equal to minus dz. So therefore what is I1 now? So I1 is equal to integration of, this is cot square x into, what is cosec square x dx? It is minus dz. Sorry, this one is, actually this is not cot square x. So actually in this case, this cot x is z. isn't it? We have assumed this cot x as z, so it is z square. So it is z square into, what is cosec square x dx? It is minus dz, right? So, or what is I1? Or I1 is equal to, minus sign is taken outside, minus integral sine z square dz, minus integral sine z square dz. So what is this integration? Or I1 is equal to minus, this is z cube divided by 3 plus c. So now what is the value for z? Actually the z is cot x. Or I1 is equal to minus 1 upon 3. What is z cube now? Since z is equal to cot x, what is z cube? It is cot cube x plus c. But this is the value for only I1. But in this case, we have to get the value for I. So let us put this value for I1 in I. So therefore, I is equal to, what is I1? It is minus 1/3 cot cube x. You don't have to write down the c because c is already written out here. Then write down plus cot x, right? Then plus x plus c. So this is the final answer. So this question is also very, very important. You can mark it. So I think you have understood it. So similarly, you can evaluate this integration. Because instead of cot x, it may be tan. So integration of tan to the power 4x dx. So you can evaluate this integration at home. So this is your homework. Okay. So instead of cot to the power 4x, there is tan to the power 4x dx. So similarly, you can do it. Here the method is tan square. You can break this term, tan square x into tan square x. And one of these tan square x should be changed into sec square x minus 1. Okay. Then separate the term. Then you can easily evaluate this integration. So this is your homework. Okay. So you can copy it. So now we'll do question number 10, that is integration of cot to the power 5x dx. So how can you evaluate this integration? So in this case also we can break the term cot to the power 5x, and you know that the differentiation of cot x is minus cosec square x. So let us break the term as cot cube x into cot square x. And let us change that cot square x in terms of cosec square x minus 1. So first of all, let us write I is equal to integration of cot to the power 5x dx. Or I is equal to integration of, it can be separated as cot cube x into cot square x dx. Okay. Now you know that the differentiation of cot x is cosec square x. So let us convert this cot square x in terms of cosec square x minus 1. Or I is equal to integration of cot cube x, and within bracket you can write cosec square x minus 1 bracket closed. Then you can write dx. Is that clear? Because the differentiation of cot x is cosec square x, so we have changed this cot square x in terms of cosec square x minus 1. Now let us separate the term. Let us multiply and separate integration of integration of, this is your cot cube x cosec square x dx minus, now this is integration of cot cube x into 1 is cot cube x, then you can write dx. Is that clear? So let us keep the first term as it is because you can easily integrate it, because the differentiation of cot x is minus cosec square x, right? Next, cot cube x. Again you can separate the term here, or I is equal to integration of, this is cot cube x cosec square x dx minus integration of, it can be written as cot x into cot square x dx. So cot cube x is separated as cot x into cot square x dx. So now, therefore, I is equal to integration of, let us keep the first term as it is, cot cube x into cosec square x dx, right? Then minus integration of cot x. Here also you can change this cot square x in terms of cosec square x minus 1, because you know that the differentiation of cot x is minus cosec square x, right? So it is cosec square x minus 1, bracket close, dx. So here also let us separate the term, or I is equal to integration of, this is cot cube x cosec square x dx minus integration of, let us multiply and separate the term, minus integration of, this is cot x cosec square x dx, right? And minus into minus is plus. This minus into minus is plus. Then integration of cot x dx. Then this is integration of cot x dx. Is that clear? So now for these two terms we can use the method of substitution. So let us write them as I1, and the last one is plus. What is integration of cot x? Log, you know that the formula is log within mod sin x base c plus c. What is that integration of cot x dx? You know that it is log within mod sin x base c plus c. And these first two terms, they are assumed as I1. So let us get the value for I1. Let I1 is equal to integration of cot cube x into cosec square x dx, right? Minus integration of cot x into cosec square x dx. So now you can easily evaluate this integration. You know that the differentiation of cot x is minus cosec square x, right? So let us do the method of substitution now. Let z is equal to cot x. So let us differentiate it. Differentiating both the sides. Differentiating both the sides with respect to x. Therefore dz by dx is equal to, this is your minus cosec square x, or dz is equal to minus cosec square x dx, and let us get the value for cosec square x dx only. So cosec square x dx is equal to minus dz. So I think you have understood it. So let us put these values in I1. So now what is I1 here now? So I1 is equal to integration of, what is cot cube x? It is z cube. Z cube into, what is cosec square x dx? It is minus dz, right? Then minus integration of, what is cot x? It is z, into, what is cosec square x dx? Cosec square x dx is minus dz. So I think you have understood it. Okay. So, or what is I1? So let us simplify I1 now. What is I1 is equal to minus? Minus is taken outside. Minus integration of, minus is taken outside integral sign. Minus integration of z cube dz. It is z cube dz, right? And then minus to minus plus. Plus integration of, this is z dz. This is z dz. Understood? So let us simplify, let us integrate it. You can easily integrate them. Or I1 is equal to minus z to the power 4 by 4 plus, then next plus. So what will you write down there? What is integration of z? It is z square by 2 plus c. Or I1 is equal to minus 1/4, that is your constant. What is the value for z here? It is cot x. What is z to the power 4? It is cot to the power 4x plus half into, what is z squared? Since z is equal to cot x, so it is cot square x then plus c. So we have got the value for I1. So let us put this value for I1 in I. That will be the answer, right? So therefore, what is I now? I is equal to, what is I1 here? I1 actually here is minus 1/4 cot to the power 4x plus half cot square x. You don't have to write down the c because c is already written there. Plus log within mod. This is sine x. The base is e, right? Then plus c. So this is the final answer. So this question is also very, very important. So I think you have understood it. Similarly, you can do this problem. So you can evaluate this integration. That is integration of, instead of cot, there may be tan. So integration of tan to the power 5x dx. So you can do this problem at home. So this is your homework. So similar is the method. You can do it similarly. So similar method may be used for integration of tan to the power 5x dx. Okay, so I think you have understood it. So you can copy it. So that is your homework. That is, you have to evaluate integration of tan to the power 5x dx. Okay, so this much is for today. So we have done some problems today. So you revise all the problems at home, and also the problem that we did so far in this chapter, integration of some special form of function. So in the next online class, we'll do more problems on this chapter. So this much is for today.